Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Hello dear students and welcome to CET JEE classes of mathematics, and we are beginning the first chapter, that is sets, relations, functions and binary operations. For this chapter to be understood, you need the basic concepts that are taught in the first year, as well as the concepts of relations and functions from the second year. Now first let me start with the topic set theory. Alright, the first question that arises when you listen the word set, what do you mean by set? Okay, set, is it a group of things? Okay, so you have some students in the class, so you make a list of those students, write one after the other with comma inside a flower bracket. Is it a set? Okay, or you have some things, okay, in your bag. Let us say you have books, you have pens, you have pencils, you have erasers, you have sharpeners. Let us say you group them together. Is it a set? Okay, so you can think about any materialistic things or animate things. Do they fall under the category of sets? So that's the question that arises when we listen the word sets. Now, how do you define a set? It is a well defined collection of objects. Alright, so it is a well defined, this word is important. It is not just a collection of objects. It is not just a collection of objects. It must be well defined. It must be agreed upon by everyone. Alright, everyone must agree upon the same set of things. When we hear the word best cricket players of India, each student will write a different set, is it not? Can you make every student to agree to the same members of that set, best cricket players? Okay, some people may include Mahendra Singh Dhoni. Some people may say he has become old, he is not no more playing well, so therefore he is not best. So there are different opinions, correct? So whenever you listen the word best and all those things, it's not well defined. Alright, famous, popular, best, all those things are not well defined. Okay, so each person will have a different opinion. But let us say you write all the cricket players of India, all the international cricket players. Okay, let us say all the international cricket players that have represented India. So then you will have a definite list, same list, everyone will have the same list. Okay, you can Google and find out who has played and who has not played for international matches for India. Okay, and you can get the same list. Okay, you may forget, but that does not mean that your list is perfect, correct? You may forget to write a name and then you say, see, he has written one name extra, I have written one name less, therefore they are not equal, we don't have same opinion. You can't say like that. You have missed one name, you must include, then only your set will be complete, correct? Okay, therefore it is well defined. All the players, best players, not a set. So it must be well defined. Simple thing, everyone must have the same list. That's what you remember. Well, now what is a finite set? Finite set, yes, it is countable. Okay, you have a definite number of elements. You have a definite number of elements. Okay, you write all the students in the class, all the students in the class. Okay, which class, that must be definite. Okay, second PUC science class, both A and B section. Then you have a definite list, and that can be counted, so it is a finite set. Infinite set, let us say you have the stars in the sky. Simple in maths, you have natural numbers. Okay, you have set of natural numbers, set of integers, you have set of real numbers, you have the complex number set. Okay, you have rationals, irrationals, all those are infinite. All those are infinite, they never end. Natural number does not end anywhere. Integers, they don't end in the negative side, don't end in the positive side, it goes up to minus infinity and up till plus infinity. Real numbers, between each real number you have again infinite real numbers, correct? Okay, so let us say this is 0 and this is 1. So 0 is a real number, 1 is a real number. Between 0 and 1 there are infinite 0.1, 0.2, 0.3, 0.4, 0.01, 0.02, 0.03, 0.001, 0.002, 003, 004, again 0.00004, all that, everything is there. So you take between 0 and 0.1, 0 and 0.1, again in between that you have infinite. Again between any two real numbers there are infinite real numbers. Well, you have studied about intervals, correct? Okay, how do you represent a set of real numbers? You cannot represent the set of real numbers like this, you cannot list them with a comma, you cannot do that, therefore you need an interval. So interval represents all the elements, let us say 0, 1. It does not mean that it is 0, 1. These are not same. These are not same. Here you have only two integers, 0 and 1. Here you have all the real numbers between 0 and 1. 0.1, 0.2, 0.01, 0.001, 0.0001, everything is there. And 0 is included, 1 is included. If you write like this, 0 is not included, 1 is also not included. But you have 0.9, 0.99, 0.999, 0.99999, everything is there. Here you don't have 0, but you have 0.000001 is there. Again, you can add as many zeros as you want. I hope you understood the difference. Okay. So when do you need a interval? To represent real numbers. When do you need a set enclosed by a flower bracket? When your elements are specific, okay, natural numbers, integers or things, objects, you can use this set. Okay, well, and then there is a roster method and rule method. You know that roster method means you list all the elements. Rule method is you write a rule. X is natural number and x is less than 4. Then what are the elements you must write? Natural numbers starting with 1. Okay, so both are the same sets. This is a rule method, this is a roster method. Set builder method, this builds the set. This is already built. This is a roster method. Okay, if you list all the elements, roster. If you give a rule, then it is a rule method. This one, set builder method. Anyway, next, what do you mean by number of elements of a set? See, if A is equal to 1, 2, 3, then what is the number of elements in A? 1, 2 and 3. You can have anything. You can have 3 alphabets. You can have X, Y, Z. How many elements are there? 3 elements. There are 3 elements. That's the meaning. Okay, so that is number of elements. Number of elements. All right. You can also say cardinality. Cardinality of cardinal numbers. Okay, cardinal numbers are counting numbers. So cardinality, how many numbers are there? So that is about n of A. Next, what do you mean by empty set? Okay, so empty set means you don't have any element. For example, I give an example of x belongs to natural numbers and x is not equal to x. So which element do you write here? Which element do you write here? So can you write 0? 0 is not natural number. Can you write 1? Can you write 1? Do you say 1 is not equal to 1? 1 is equal to 1. You cannot write 1. Can you write 2? But 2 is equal to 2. It should not be equal. Therefore 2 cannot be written. 3? No. 4? No. 5? No. Can you write anything? You can't write anything. So this is an empty set. That's an empty set. You have other symbol phi. This is phi. Phi, Greek alphabet. Okay. So this is phi, or you can simply write this. Both mean the same. But don't do the mistake of writing this. This is not an empty set. This is a set which includes phi. So this has one element. This has one element. Here number of elements is 0. Here the number of elements is 0. You don't have any element. Here you have one element. So don't do this mistake. This is not empty set. This is an empty set. This is also an empty set, but this is not an empty set. Remember that. So that is about empty set. Now what do you mean by singleton set? This is a singleton set. You have one element. Number of elements, if it is 1, then it is a singleton set. You have the number 2. You have x. You have let us say what, car, one element, anything. Okay. So this is a singleton set. Well, so that is about these definitions. Now let's move on to the next point, 7, and I need this space to explain that. Well, you have a subset. Now, what is a subset? Understand, you have A 1, 2, 3, 4, 5. Now, the set B is 1, 2, 3, 4, 5, 6. Can you tell me which is a subset of which one? A is a subset of B. I am saying A is a subset of B. How do I write? See, this sentence is long. Instead of writing this much, I can simply write subset. Okay, this is not C. This is little elongated. Okay, little elongated subset. In some textbook you will find this subset and equal and only subset. Okay, so some write like this and some people write only one notation. Okay, I'll explain the difference. Okay, I'll explain the difference of this. Well, now when do you say it is a subset? What is the definition? Every element of A must be present in B. So A is a smaller set of B, subset. It is a subset, sub-inspector, inspector, and under that you have sub-inspector. Correct? Okay, you have a way, you have subway, under that subway. Alright, so this is a smaller set of B, smaller set of B. Now can you say B is a subset of A? When B will be a subset of A? If every element of B is present in A. Every element of B, is it present in A? No. The element 6 is not present in A. Element 6 is not present in A. Therefore, B is not a subset of A. Not a subset is this symbol. Okay. Now, do you say A is equal to B? When A will be equal to B? If A is a subset of B and B is a subset of A, then we can say this. Okay, so if A is a subset of B and B is a subset of A, then we can say A is equal to B. Otherwise we cannot. If only one thing happens, then they are not equal. See, now this is not a subset. B is not a subset of A, therefore B is not equal to A, even though it is A is subset of B. I hope you understood. They must have the same and exactly same elements. They should not have equal number of elements. They should have the exactly same elements, A and B. Then they will be equal. Otherwise they are not equal. Now, coming to this proper subset. Okay, so this symbol is proper subset. This symbol is equal. Okay, so imagine you don't have 6. You don't have 6. Now, do you say A is a subset of B? Yes, A is a subset of B because all the elements of A are present in B. Therefore, A is subset of B, and it is also equal. It is also equal. Therefore, some authors, in some textbooks, you find this symbol. If it is a proper subset, now you have one element extra in B. They are not equal. Then we say it is a proper subset. Otherwise, it becomes improper. Okay, so what is a proper subset? A, all the elements of A are present in B, but A is not equal to B. Okay, but A is not equal to B. If it is equal, then it is improper subset. Trivial. Okay, trivial, there is another meaning. Understand what is a proper. Opposite of proper is improper. Okay, proper means they are not equal. Okay, it is a proper subset. Properly small. They are not same. They are not equal. Properly subset. Okay, subset can also be equal, but now it is not equal. Therefore, it is properly subset. Properly small set. Therefore, it is proper subset. Well, so here it is proper subset. Which is proper subset? A is a proper subset of B. Okay. Next, what are the possible subsets? See, I will write only these things. Okay. How many subsets are there? How many subsets are there? First, you have empty set. Second, you have singleton set. Okay, and then you have 1, 2 and 1, 3, 2, 3, 1, 2, 3. So totally how many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 subsets are there. Okay. Now when you write this as one set, see what is this? This is nothing but empty set. So I'll just write 5. Okay. I'll just write 5. Then I'll write 1. Then I'll write 2. Then I'll write 3. Then 1, 2, and then 1, 3, and 2, 3, and then this is nothing but A itself. This is nothing but A itself, full set. All right. Now set of all subsets. Set of all subsets is called a power set. So understand the definition. What is a power set? P of A, it is written as P of A, set of all subsets. Now in that you have some trivial subsets, improper subsets. See, this is not a proper subset. This is improper subset because it is equal. When it will be proper? If it is not equal. See, this is a proper subset. You have properly less elements than this. Okay. Proper subset, proper, and this is also proper. You don't have equal. Okay. So that is about improper subsets. Which is improper? Only one. So improper subset is only one. But when it comes to trivial subsets are 2. So which subsets are trivial? 1 is empty. It will be subset of all the sets. You write any set, 5 will always be there in power set, and the full set also will be there always. Okay, so 5 and A are trivially, automatically, by default, automatically they will be there. These two will always be there wherever you go. Okay, whichever set you take, these will always be there. This will sit in the first place, this will sit in the last place, always fixed. They will reserve the seats. Okay, so trivial are 2. Improper, which is not equal, which is equal is improper. If it is not equal, then it is properly less, proper subset. I hope you understood so much. Now, last one thing we must understand, that is n of P of A. What is n? Number of elements of power set. Okay, how many elements are here? What is number of A? 3. Correct. Number of elements is 3. And how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. You have 8. And what is it in terms of this 2 cube? So, if n of A is m, then what is n of P of A? 2 raised to m always. Okay, so that will be like 2 square, 2 cube, 2 to the power 4, 2 to the power 5, it goes on like that. So the formula is this, 2 to the power m. If number of elements in the set is m, number of elements in the power set is 2 raised to m. So number of elements in the power set is 2 raised to m. Please remember this formula, very important, okay, for CET. Well, so that is about a few basic definitions of this chapter set theory. Let's move on to solve a few questions based on this knowledge.
Don't forget to like our video and subscribe our YouTube channel for all the updates.